Hello.
Hi, Miss.
Yeah. So in today's session, we will learn about circle theorem. So before we start learning about circle theorem, let's see the parts of circle. Already you are about aware about the parts of circle. Just this is a recap. So you know every circle will have a center, and then through the center you have a line passing through on the circumference of the circle from one end to another. This is called as diameter, and then from the center to one end of the circumference of the circle, you have this length. This is called as radius. And then you have a chord. So chord is from one point on the circumference to the another point on the circumference. Okay, so we can say that diameter is the longest chord of the circle. Okay, now you see that as soon as we draw a chord, our circle is divided into two parts. So these parts are called as segment. So I will show you now. So you can see here this lightly shaded part. This is minor segment, and here if I do, I will shade this part. When I shade this yellow shaded part, this is your major segment. Okay,
Okay.
this much is clear to you. And then you can see here a word mentioned as semicircle. A circle is divided into two equal parts by its diameter. So as you know that diameter passes through the center, so it divides the circle into two equal parts, and each part is called a semicircle. You can say half of the circle. Right. Now you can see there is another word mentioned as sector. So what is a sector? Sector is the area enclosed between the two radius. See, so here is one radius and here is another radius. So in between these two radius, this is the enclosed area. So because this is smaller part of the circle, so we call it as minor sector. And I will show you now which is major sector. So this is also enclosed in the radius, but this is the major sector. I hope this is clear to you what is major sector and minor sector,
Minus. Yeah, Miss.
right? Okay, so here we learned one minor segment, major segment, minor sector, major sector. Okay, now let's see the other terms. So you can see here a word mentioned arc. What is an arc? This arc is nothing but a part of the circumference, right? Now you can see here, so when we have a sector, this is the sector. Now when you have a sector, you also have this circumference of the circle, a part of circumference of the circle, right? Okay, so you can see, you can say this part as arc. Is this clear to you?
Yeah.
Okay, now we can find there are two arcs in this circle. If I do it like this, see the blue one is occupying the major part. So we call it as the major arc, and the red one is occupying the smaller part. So we call it as the minor arc. Is this clear to you? Arc?
Yes, Miss.
Okay. Now there is another term which is again very, very important. You have many theorems on this. So you can see tangent. Tangent is a line passing, it is passing through the circle and it touches the circle at only one point. Is this clear to you? Tangent is a line
Yes.
which passes through the circle and touches the circle at one point. When a line touches the circle at 2 points, we call it as secant, right? This is secant, whereas when it is touching at one point, we call it as tangent. I hope you have recalled all these terms. Yeah. Now let's start with the circle theorem. So
Okay.
you have symmetry properties of circle. So what is this? Now see, the perpendicular bisector of a chord passes through the center of the circle. So here you can see, here we have a chord A B. Okay, what it says that perpendicular bisector of chord. So this is the chord, and this chord is bisected by this line, and it is a perpendicular bisector. Perpendicular bisector means it forms 90-degree on the chord. When this happens, when this is perpendicular bisector, then definitely it will pass through the center of the circle. Understood?
Yes.
Okay, now the word perpendicular bisector of chord means when we say perpendicular bisector of chord, suppose your chord is AB and this is the perpendicular bisector. So, as the word says perpendicular, so this is 90-degree, and it says bisector means the whole chord is divided into two equal parts. If AB is 10 centimeter, then let's mark here C, then AC will be 5 centimeter, BC will be another 5 centimeter. Is this clear?
Yeah.
Now let's see the next property. Okay, you have a question over here. Chord AB is drawn in a circle with a radius of 7 centimeter. So chord AB is there. So you can see here we have chord AB and the radius of the circle is 7 centimeter. If the chord is 3 centimeter from the center of the circle. Okay, now there is a chord from the center of the circle on AB, this is 3 centimeter. Find the length of the chord. Okay, so you have to find the length of the chord. Length of the chord means you have to find AB, right? So is there any idea we can find AB? Yeah. So I will
Uh,
tell you. Yeah. Yeah, you can speak.
I'm not. Oh, find the triangle. Like the
Yeah.
a 3 square plus 4 square is equal to c square. That thing. Like they have the theorem, and then you double the answer.
No, you will go with the Pythagoras theorem. See, here we have 90-degree, and we know that AB is, see, OP is perpendicular bisector of AB, right? OP is perpendicular bisector of AB. Since it is perpendicular bisector, so you have 90-degree. When you have 90-degree here, we get a right triangle. And then finding the length of AB is nothing but you find the length of PB and you double it because AP is equal to PB, right? AP is equal to PB. Therefore, AB is equal to 2 times of PB, right?
Yeah.
So we can work on the length of PB. So you will follow the Pythagoras theorem, and then so this is your hypotenuse. So we will go with PB square equals OB square minus OP square, and then PB is equal to square root of OB is 7 squared minus OP is 3 squared. Hence you have here PB is equals 49 minus 9, that gives you PB equals, that gives you root 40. Is this clear to you? Is this clear
Yeah.
to you? Okay. So root 40, and then what we can do is AB will be double of root 40. Since PB is equal to root 40, we can simplify this, right? So how can you simplify this? 2 times 2 times 2 times 5, that will be 2 root 10, and then we can double it. So AB is equal to 2 times 2 root 10, and that will be 4 root 10. I hope this is clear. Okay.
Yes.
Now, the next one is equal chords are equidistant from the center. It means that in a circle, if you have two equal chords, so suppose here you have a chord CD and here you have a chord AB. So it says that the chords are equal in length. Suppose if this is 5 centimeter, then this is also 5 centimeter. If the chords are equal in length, then the distance from the center will be the same. So if if I say that OM is 6 centimeter, then ON is also 6 centimeter. Is this clear?
Yes, miss.
Okay, we can also say in other words that chords that are equidistant means if you have two chords, okay, and then if I say these two chords AB and CD both are equidistant. Equidistance means the distance between them is from the center is same. So from here to here OP. Let it be 3 centimeter. And from here to here, it is 3 centimeter. So chords that are equidistant means from the center, which are at equal distance, are equal in length. It means that AB is equal to CD. So if the distance from the center is equal, then the length of chord is also equal. So we can say that AB equals CD. Is this clear?
Yeah, miss.
Now, now here is a question. O is the center of the circle. Radius is 11. AB and CD are chords. So AB is equal to 14. If OX is equals O, what it is? OX equals OY. OX equals OY. Right? Find the length of OY. So we need to find the length of OY. How can we do that? See, OY is this length, right? So you can see here this marking that shows that this is the perpendicular length, right? Okay, so that
Yeah.
makes it a right triangle. So in this right triangle, you have this one as 11 centimeter. Okay, and then since this is perpendicular line, so this perpendicular line divides CD into two equal parts, right? CY equals CD, correct?
Yeah.
Okay, and then also it says that OX equals OY means the chords are at same distance, means chords are equidistant, correct? So when the chords are equidistant, then the length of chords are equal, right?
Yeah.
Because see it says that OX is equal to OY, that makes chords equidistant. Okay, you see OX is equal to OY, that makes chord equidistant. Therefore, AB is equal to CD. When you say AB is equal to CD, then AB is 14. So CD is also 14, right? Yes.
Yeah.
And then you can see the marking here that it says that this is 90-degree angle. You can see this one 90-degree. It means this line is perpendicular bisector of this line. So if the whole length is 14, so this YD is half of 14, that is 7. I hope this is clear to you. Now, this makes our work easier to calculate the length OY. So, you have a right triangle OYD where you have to find the value of OY. So, we will have OY square equals OD square minus YD square. Is this clear?
Yes.
So we can write OY equals OD square is OD is 11 squared minus YD square is 7 squared. So you get here 121 minus 49, right? So 11 minus 9 is 2 and 11 minus 4 is 7. So you get OY is equal to under root of 72. I hope this is clear to you. Yeah? Hmm.
Yeah.
Okay, so we can simplify it more. So how can we write this? 2 times 2 times 2. See, 8, 8 to the 16, and then, wait, 4, 8 nines is 72, right? So you will have here 8 into 3 times 3. So we can take out common. So 2 into 3 will come out and then you have here root 2. So you get the answer as 6 root 2. Okay.
Yeah.
Now let's see the next one. Okay. Now this is very important theorem. You can mark it very important. You are going to use it many places. Now you see that two tangents drawn to a circle from the same point outside the circle are equal in length. What it says that, so from the same external point, like here we have P, if we draw two tangents to the circle, so as it is drawn here AP and BP, the tangents will be equal in length. So PA is equal to PP. Is this clear to you? See,
Yes, Miss.
when you have simply see an external point, you have a circle and you have a tangent drawn like this, means this and this tangent length will be equal. I hope this is clear. I guess this is the easiest one. Hmm.
Yes,
Yeah.
Miss.
Now let's work on this question. See, there is a question based on this property. You can see here, this is a circle with center O, and this is a point outside the circle which measures 42 degree, and then you have to find the value of x, right? So you can see that, yes. So to find the value of x, there are few things which we know. See, we know that this is a tangent. Because this is a tangent, so this is 90 degree, because radius and tangent forms 90 degree. Okay, this is one thing. Another thing also we can say that, consider triangle MLN. Okay, since these tangents are equal, so ML is equal to LN. That make, oh sorry, MN. It is not LN. ML equals MN. So when you have ML is equal to MN, then this makes an isosceles triangle. Then this and this will be equal. Am I right?
Yes.
Okay, so we can find these angles. 180 minus 42 over 2, we can do 10 to 8, and 7 4 is 3. Okay, and then divide by 2, that gives you 69 degrees. So this is 69 degrees and this is also 69 degree, correct? Yeah.
Yeah.
Now, another thing you have to know that when you have a tangent and radius forms 90 degree. Okay. So x will be 90 minus 69. That gives you 21. Is this clear? Good to go?
Yes, Miss.
Now, we have another properties, that is angle relationship in circles. Okay, so in circles, what are the angle relationship? So this is one very important. Always you should take care whether the you have, if it is mentioned you that some angle is formed via diameter. Okay, this is very important to know. Now the angle in a semicircle is a right angle. Okay, now you know when we have a semicircle, when you have the diameter, a diameter divides the circle into two parts, that is two semicircles, right? So angle in a semicircle means from these 2 points, if an angle is formed, then it is always 90 degree, or you can call it as right angle. Okay, now you can also say it like this. See, from these 2 points, if I have angle drawn like this, then I will say this is 90 degree. Okay, now if I have like this from these 2 points, this is also 90 degree. Clear?
Yeah.
Now we can also have many 90 degrees like this. Say from these 2 points, if you have like this, then this is also 90 degree. Okay, this is again very important circle theorem. Now let's work on this question. So here you have to find the value of x. So let's see what is the given thing here. Here you can see a circle, and here you can see the center of the circle. As soon as you see the line is passing through center of the circle, and it means there is a semicircle and angle is drawn on the semicircle, immediately you mark this as 90 degree. Is this clear to you?
Yeah.
Okay, now we can go with the angle sum property. Suppose if you have a triangle ABC, one angle is 20, another is 90, and then we have to find the angle B. It must be equal to 180 degrees. So angle B is equal to 180 minus 110 degrees, that is equal to 70. Is this clear to you?
Yes.
Okay, so we got angle B equals 70 degree. Now, if you look at this diagram carefully, you can see this parallel line marking here, right? Yes, it means that
Yes.
this line is parallel to BC. Okay, so when you have two parallel lines, there are certain angles formed here. Okay, now you see that x and 70. See, now when you have like this, so when you have x here and you have 70 here, so if you remember, this is called as co-interior angles, and sum of co-interior angles is 180 degrees. So x plus 70 degree is equal to 180 degree. Hence x is equal to 180 degree minus 70, which is equal to 110. I hope this is clear to you.
Yes.
Okay, now let's go to the next one. Okay, we have another question here. We have to find the value of x here. Okay, nothing else is written, but yeah, there are many markings you can see here. So here this marking and this marking says that this is a right triangle, and then this sorry, not right, this is isosceles triangle, and then this and this marking, it says that this another triangle is also isosceles. Now what is most important thing to observe is that we have a diameter, means we have angle formed in the semicircle. So as soon as we see that angle is formed in the semicircle, we mark this as 90 degree. I hope you remember this, right?
Yes.
Now, since this angle is 90 degree, so these two are have to be equal, because this is isosceles triangle. It is already marked. These two side lengths are equal, right? So now 180 minus 90 will give you 90, and then 90, half of 90 is 45 degree. So this is 45 degrees and this is 45 degrees. Is this clear?
Yes.
Okay, now you have to look for another theorem here now, that see, you can see one line here. Okay, now this is 45 degree, and then we have to measure this one. So what will be this? We know that angles on a line is 180 degree. Okay, sum of the angles on a line is 180 degree. So 45 plus something, let me write this as a, is equal to 180 degree. Hence a is equal to 180 minus 45, that will give you 135. So this is 135, right? Okay, now once this is 135, now again you look at the markings given here. So marking says that this length and this length is equal. It means this angle and this angle is equal. If this is x, this is also x. Now if we consider this triangle, this angle sum property of a triangle is sum of all the angles of a triangle is 180 degree, right?
180 degrees. Yeah.
Yeah, so 135 plus x plus x is equal to 180 degree. Hence you have 2x equals 180 minus 135, so that will give you 45 degrees. So x
Yeah.
equals 45 over 2, that is 22.5 degrees. Is this clear to you? So this
Yes, miss.
x is 22.5, right? Now
Yeah.
let's see another one. Now here, the angle between the tangent and radius is right angle. This is very important. The angle between the tangent. See, you can see a tangent here. Tangent is a line touching the circle at one point. And it says angle between the tangent and radius. And this radius is always a right angle. So here 90-degree angle is formed. Now let's see if we have few questions based on this. Yeah, good. We have this question. Now you see that there is a circle with center O, and we can see that there is a tangent touching it at one point. So this is a tangent. Okay, so just now we learn the tangent and the radius. This is radius, right? This and this both are radius, correct? So this is radius. So radius and the tangent form 90-degree, right?
Yeah.
Okay, so because we have a radius and tangent forming 90-degree, so we have a right triangle here. So as soon as you see the right triangle, you must remember Pythagoras theorem if you have to find any of the missing length, right? So what is Pythagoras theorem? Hypotenuse square is equal to perpendicular length squared plus base squared, right? And what is hypotenuse? Hypotenuse is the side opposite to the 90-degree. Always you have to remember this. You cannot just say it's the longest side and this and that. It is always opposite to 90-degree. So here we need to find the length of hypotenuse, that is x. So we write x squared is equal to perpendicular length is 5 squared plus 12 squared, and x equals under root of 25 plus 144, and x equals under root of 169, that is 13. Is this clear? X
Yeah.
equals 13 centimeter. Okay, now let's move to the next one. So here you have another question, and you can see again there is a tangent touching at a point. You can find a radius here, and the tangent and radius form 90-degree angle. Hence, to find this base length, we can use Pythagoras theorem, and this is side opposite to 90-degree, which is hypotenuse. So we can say x squared equals 10 squared minus 6 squared, and x equals is 100 under root of 100 minus 36, that gives you 64, and x equals 8 centimeter. Any doubt?
No, miss.
Okay, now let's move to the next question. Yeah, now this is another good question. So you can see a tangent from the external point, right? As soon as you see two tangents from the same external point, you remember that they are same in length. So if this is 17 centimeter, this is also 17 centimeter. Am I right?
Yeah.
Then you can see that from center O we have a radius, right? And this is radius is 5 centimeter. So this length is also 5 centimeter. And then radius and tangent form 90-degree. So here also radius and tangent form 90-degree. Is this clear?
Yeah.
Now, your question is to find this length x. Now, what does x form? What side of this right triangle? X is what? It is perpendicular, base, or hypotenuse.
Base.
X is base. So, x is opposite to 90-degree, right?
Yeah.
So, opposite to 90-degree, what we have?
Up. We have x.
Opposite to 90-degree. This length.
Ah, hypotenuse.
Yes, don't forget that. Okay, so this
Yeah.
is your hypotenuse. So when you understand, okay, this is hypotenuse, go with the Pythagoras theorem. So your Pythagoras theorem is x square equals 5 square plus 17 squared. Okay, so
Okay.
yeah, so you can write this as x equals under
25
root,
plus.
yeah, 25 plus, say what is 17 squared?
We, is it?
289.
Yeah. 289.
Okay, so you
Yeah.
get x equals now 9.4, 1. And now this square root of 314. What will be square root of 314? One moment. 954, 1, 9, 10, 11. Yeah,
17.72.
one second. You can check in your calculator.
Yeah.
You check your calculator because this is not a square number. We will get in decimal.
17.72.
17.72. Okay, so you can also write this as 17.7. So value of x is 17.7 centimeter. Any doubt until here?
No.
Okay, very good. Now let's move to the next rule. Angle. The angle at the center of a circle is twice the angle at the circumference. Okay, so what it says, suppose if you have a circle. Okay, now from the same points we have angle at the center, and from the same point we have angle at the circumference. So if I say if this angle is 25, then this is 50, right? Angle at
Okay.
the center is double of angle at the circumference. Okay, now you tell me, if I say that here I have 100 degrees, then what is the angle formed here?
Okay.
I'm asking you.
So it's 100, then that's 50.
This is 50 degrees, right?
Yeah.
Okay. So now tell me one more like this. If I have 30 degrees here, then what will be the angle measure here?
60.
Very good. See, so here are few criterias of angle at the center and on the circumference. So you can see that from the point AB, you have angle on the circumference as angle C, which is shown as X, and then angle at the center from point AB is AOB. So this is X and this is double of X, that is 2X. Got it?
Yeah.
Same thing can be shown like this also. See, from point AB we have angle at the center like this, and from the same point we have angle at the circumference here like this. So angle on the circumference is x, angle at the center is 2x. Clear?
Yeah.
Now there is one more case, two more cases are there. Now you see, so when you get the question you have to remember this. Okay, it can be like this also. Now you see that from point AB we have angle at the center 2x, right? This is angle at the center from the same point, and the same line is going on the circumference like this, and then we have another line here. So this is angle on the circumference, which is half of angle at the center. So this is x. Clear to you?
Yeah.
Now, if you see here AB, from the point AB, a reflex angle is marked. Okay, so you have to be careful here. This is your reflex angle, angle at the center, 2x, and then this is the angle on the circumference, which will be half of this one. Is this clear to you?
Yeah.
Okay, now let's see some problems based on this. Now, you have a circle and angle on the circumference is 36. So what will be the angle here as soon as you see this 36? What can we say? Hmm?
Sorry?
What is the measure of angle O? If angle at the circumference is 36, then angle at O is
72.
very good. And now you have to observe one thing here. See that it says that, see these two markings. It means that this is an isosceles triangle and this angle is equal, right?
Yeah.
But your question is you need to find this angle and this angle. Now,
Wait,
if
it's an
you,
isosceles, right?
yeah,
So 180 minus 72 divided by 2.
very good, because you have the radius here. So these two lengths are equal in the radius. So we get an isosceles triangle. So x will be 180 minus 72 over 2. Okay. So what I
Yeah.
will get here?
Uh, 180 minus 72 is like 108 divided by 2 is 50.
54. Okay. So we got x equals 54. And now how to find this y?
Is it also divided by 2?
Why?
I don't
No, no, no. Y is not part of this triangle, right? This is part of this triangle, the another one.
Okay,
Okay.
okay.
Okay. Now you see that we have got the measure of x. Okay. And then if you look at this triangle, this is also isosceles triangle. It means this angle is equal to this angle. So if we find this length, this measure, then we can subtract x to get y. Got it?
Yeah.
Okay, so let me mark it before solving. One second, that will make your work easier. See, let's say A, B, C. Okay, so angle B and C we have to find. Angle A is equal to 36. So, see, angle B and C, let me mark this as A. This is also A. So, we can write it as 36 plus A equals 180 degree. 2A equals 180 minus 36, and then 10 6 4 and 7 3 4 and 1. So A equals 72, right?
Yeah.
Okay, so if this whole this length, this measure is 72, and you know that this part is 54. So this part is 54 because x is 54. So y equals 72 minus 54. Is this clear to you? Very
Ah,
good.
okay.
Yeah. So y
Yeah.
is equal to 18 degrees. Clear?
Yeah.
Okay, very good. Now let's see a few more questions.
Okay.
Okay, so you have another theorem here. Angles in the same segment are equal. So you know what is segment? So you can see here very clearly this unshaded part is one segment and the shaded part is another segment. Here you can see very small minor segment and the large major segment. And here you can see this unshaded part is one major segment and this is minor. So this theorem says that angles in the same segment are equal. What does it mean? Actually, whenever you see this thing, like it is like this. So segment is formed by these 2 points AB, right?
Yeah.
Okay, so here, because this is the dividing line, now in the same segment means this is the major segment. From this point we have one angle here, and from the same 2 points we have another angle here. So these two angles will be equal as they are in the same segment. Is this clear to you?
Yeah.
Now if we look at this minor segment, and there is a chord here, you can see that CD, and from these 2 points I have two angles formed in the opposite this segment. So here one in the major segment, so these two angles will be equal. Clear?
Yes. Okay.
Now another you have here, this line is dividing this circle into two segments. From this point I have an angle here, and from these 2 points another angle here. Since these two are in same segment, so they are equal. Clear?
Yeah.
Okay, let's see few questions. Okay, we missed one. Yeah, come. Okay, now if you look here, see, this is, let this be point AB. Okay, and then this is, here we have two angles formed in the same segment. Okay, now I'll
Yeah.
show you, this is the minor segment and the unshaded part is major segment. So you can see that two angles formed in the major segment, right?
Yeah.
So what will be the value of A if this is 72? A will be,
It will also be 72.
very good, because A and 72, they both are in the same segment. Now let's see another. Okay, this looks good. Okay, so here you have to find quite a few things. Like, see, you need to find what is value of P, what is value of Q. Given is 40 degree here, given is 75 degrees here. Okay, so you have to use the vertically opposite angle rule, because this is 40 degrees, so this is vertically opposite, and this one will be 40 degree. Am I right?
Yes.
Now you see that from these 2 points, see, look here, we have, one sec, one sec. So from these 2 points, you have this angle like this, right?
Yeah.
And from these 2 points, you have another angle like this. So see, this is one segment, and this Q and this is in same segment. Am I right?
Yeah.
So what can you say? Value of
Uh,
huh?
is value of wait value of D is
Q, that is Q.
oh
Hmm.
Q.
Hmm.
Oh, that's Q. 75.
75, but 75 is here, right? 75 is not here in the segment, correct?
40. I think. Yeah.
40.
Yeah.
Yeah, why you think? You have to be sure about that. See, from this point, we have, like, this is the minor segment. In the major segment, we have Q, and in the major segment, another angle is this one, 40 degree. So, Q is also 40 degree. Is this clear to you?
Yeah.
Now, if you look carefully here, now you can see that here you have angle P, which you need to know what will be the measure of angle P. So you can see that if we look at these 2 points, now this is one segment and now this is another segment. Okay, so you can understand here very clearly that P is P and this is in same segment. So for following the angle sum property, we will have 75 plus 40 plus, let me mark this as A, plus A is equal to 180 degree. So you will have here 115 plus A equals 180 degrees. So A equals 180 minus 115, that is 65 degrees. Is this clear to you? So if this one is 65 degree, A is 65, P is also 65. Is this clear?
Yes.
Any doubt?
No.
Okay, so here we conclude the circle theorem. Okay, see you in the next class.